Hello everyone. I love JavaScript and I love building applications using JavaScript. Actually, I have been using JavaScript for many years and sometimes I had problem understanding how are the function callbacks executed in different ways. I had situations like what? Why is this function executed before the other one? And later on, after diving deeper into the internals of browser and how our JavaScript engine executes our JavaScript code, it was quite easier to figure out the root cause of the problem. And I would like to share all those things with everyone. Actually, we can find JSConf videos related to this topic in YouTube, and I have included all those videos at the end of the slide. You can watch all those videos later on. So let's start with a quiz. Maybe you can try to pause the video and try to predict the output of this piece of code which has console log statements. You just need to predict the right sequence of the console log messages. So it has set timeout, two set timeouts, promise, two promises, and some console logs in it. Maybe just try to predict the output of this piece of code. Okay, now I'm going to reveal the output of the code. Let me try to open the example in the codepen first and reveal the answer. So here you can see the first log statement is start and then int, then promise 1, promise 2, set timeout 1 and set timeout 2. You can see the same result in the code pen as well. So here we have the same code, console log start, set timeout and promises, and it prints start int promise 1 promise 2 set timeout 1 and set timeout 2, which means the result is right because the same strategy has been implemented in all the browsers, mainly Chrome, Firefox and Safari. And I will explain the reason how this piece of code is executed in the browser in the coming up slides. So before moving further, let's try to understand brief architecture of the browser. So browser actually consists of different components. The first component is user interface, which is actually the components which is displayed to the user. For example, this address bar, these buttons, next and forward buttons, refresh button, these belongs to user interface component. Similarly, it has browser engine and rendering engine. Rendering engine actually is responsible to parse HTML and CSS DOM and execute or paint those things on the browser. And browser engine is like a bridge between rendering engine and user interface. Browser engine actually is responsible for manipulating rendering engine. For example, if we refresh the page, browser engine tries to manipulate or calls API of the rendering engine to refresh the page. If we click on back and forward, it tries to do the actions based on the user events. Similarly, the networking component is responsible for fetching the actual content which should be displayed in the browser. For example, if we type in www.google.com, it goes to the remote server, fetch the HTML and CSS content, and the browser rendering engine actually executes those HTML and CSS on the web page. Similarly, JavaScript engine is responsible for executing our actual JavaScript code, and UI backend is actually responsible for drawing basic widgets like select box or combo box. This is a programming language or platform independent module which actually talks with the operating system to use the UI widgets. Likewise, data persistent layer is responsible for handling data services like cookies, IndexedDB, web SQL, session storage, all these kind of things. So all these browser components actually work together to form a JavaScript runtime, which consists of JavaScript engine, task queue, event loop, and web DOM APIs. So JavaScript engine actually consists of call stack and the heap memory. So heap memory is actually used to store the value of the variables, functions in it, and call stack is actually a data structure which actually executes our code, our JavaScript code. Let me open the simulator and then try to explain basics of how our JavaScript code gets executed inside the browser. So this simulator was developed by a cool guy called Philip Roberts, and I would recommend to watch his JSConf video, what the heck is event loop, and it's quite useful to understand what are the things which is going on under the hood. So in this simulator you can see we have main components like call stack, web APIs or DOM APIs, and then callback queue. So in this piece of code we have console log, set timeout function, and console log int. So first of all, call call stack actually executes this line of code is start, and then when it encounters set timeout, it will delegate this task to web APIs part of the runtime, and then it executes console log int. So according to this code, after 5 seconds it will it will queue this timeout function into the callback queue. So whenever there is something to execute in the callback queue, this event loop will pull the task from the callback queue and tries to execute that in the call stack. So if I run this program, you will see the same behavior. So first of all, start delegates the work to web APIs. After 5 seconds, timeout goes here, and then immediately it is executed by the event loop in the call stack. Let me rerun the program. First of all, start goes there, and then immediately int is executed. After some time, set timeout callback function is executed. So this is the basic behavior using task queue, call stack, and web APIs. Let's go back to our slide. So likewise, like task queue, there is another queue called micro task queue. So these queues actually work on the same principle. Queue is first in, first out, but the call stack executes in the on the principle of stack last in, first out manner. Yeah. So I will come back to this slide later on, but before that we need to understand different other things. So in browser there are different sources of callback functions. So there are callback functions related to keyboard events like key down, key up, mouse events, network events, drag and drop events. Similarly, there are callback functions related to promises and browser observers. Actually, these observers, I have different blog about observers, but I'm not going to cover a lot of things about observer in this video. It's only about the callback function from the promises. So if there are callback function related to group 1, it is queued in the task queue, and if there are callback functions related to promises and observer, it is queued in a micro task queue. Why it is important to understand things which are, or callback functions which are queued in the task queue and micro task queue, because the execution strategy it is a bit different when things are queued in task and micro task queue. So let me try to explain about the event loop. This event loop, because this is like the mastermind of the runtime, so it's good to understand what is event loop actually. So actually the event loop is the mastermind of the whole runtime environment. actually is responsible to decide what JavaScript code should be executed, when should it be executed, and when does layout style should get updated or DOM changes should be rendered. So basically this is responsible for picking up the task from the task queue or micro task queue and execute it in the call stack as explained in this. From this simulator, it is responsible for picking up the task from the task queue or micro task queue is not visible here but it exists, and then execute that task into the call stack. So actually I have written a long blog related to this topic, but this slide is like the summary of this blog. And I have like a pseudo code for the event loop. Let me go through that piece of code. So according to the event loop standard event loop specification, we have an event loop which is continuously running program. For example, while true means it should be executed all the time. So the event loop actually picks up the task from the task queue. So this function actually returns a task from the task queue if it exists, and if it exists it is executed, and then in the second step it executes all the tasks in the micro task queue, and then later on it decides if there are some things which should be rendered in the browser, then it renders that in the browser. So basically each iteration is called tick. Each iteration of the while loop is called tick. So in each tick it will pick up the task from the task queue, execute it, and if there are some of the task in the micro task queue it will execute that as well. So so the thing that we need to understand is, if one of the task, let me go to the diagram. Yeah, so so one of the, if one of the task can contain multiple other tasks or other micro tasks. So in our, before picking up the task from the task queue, event loop actually verifies if the call stack is empty or not. And second step is if it tries to check, okay, micro, if some there is something to execute in micro task queue or not. So if call stack is empty, if if it has executed everything which is queued into the micro task queue, then it will pick up the next task from the task queue. So it isn't like let's say call stack is empty, and if there is something callback, for example in this case 3 4, then it will pick callback 1. It's not like that. It makes sure that call stack is empty plus micro task queue is empty, and then it will pick up the new task from the task queue. So now let's go back to our quiz. So here actually we have everything in the diagram. Let's try to execute this piece of code step by step. So first of all, console log start. Call stack will execute the first line of the code. Sorry guys. So when the call stack encounters set timeout, it will delegate that task to the web API or DOM API part of the runtime. So in the second case as well, it will delegate the task to the DOM API part. And the third case, when it encounters promise, the callback functions, callback 3 is queued into the micro task queue, callback 4 is also queued into the micro task queue. Similarly, after 0 seconds, this callback 1 and callback 2, callback 1 goes to the task queue, callback 2 goes to the task queue again. And now the strategy is, it will first of all execute console log 1 and then set timeout. It delegates to web API, set timeout again delegates to web API, promise delegate task callback function goes to micro task queue, this promise goes to another micro task queue. And then at the end it executes log.it, which means start and end is executed first. So now the event loop will not pick up the task cb1 from the task queue. It will actually pull the task cb3 callback 3 means it will print promise 1. Then it will pull cb2 into the call stack, which will print promise 2. Once this is empty and this is empty, then it will pull the task cb1 means set timeout 1, then cb2 means set timeout 2, which means start in promise 1 promise 2 and set timeout 1 and 2 are the right order which should be printed, or which this is the right sequence which is used to execute this piece of code. This is the tricky part. It's important to understand when is the queue, or when is the callback function which is queued in the microtask queue gets executed. It's before something which is in the task queue. So once we understand this, let's try to solve the other quiz. So we have a simple button which has two callback functions. So we have click add event listener click callback function 1, callback function 2. So a button has two click event listener. And let's pause the video once again and try to see what would be the right order of the message. Let me try to open this in the codepen editor. Yeah, I will open the console. Okay, now I'm going to reveal the answer. So each callback function consists of listener 1 and set timeout, timer function and promise, timer function and promise. Now let's go to the answer. So the right answer here is it will execute, so callback 1 and callback 2. When we click on the button, callback 1 and callback 2 are queued into the task queue, which is as described as shown in this diagram. So first of all, callback function 1 is queued, callback function is 2 is queued in the task queue, and then event loop actually will pick up callback function 1 to execute first. So in callback function 1 we have listener 1, so it will print listener 1. Set timeout is delegated to DOM API. Promise, it is if there is promise, the callback function inside then is queued into the microtask queue. Therefore because the set timeout had 0, it will queue st1 set timeout callback function into the task queue at the end. Yep. Similarly once it has okay, p1. Yep. So we are executing the first callback function, so it prints listener 1, set timeout goes there, promise 1 goes there, and then the execution of the callback function, all the code which is inside callback 1 is done. But before picking up the next task, callback 2, it tries to check if the JS call stack is empty or not, and then it finds okay, p1, there is something to execute in the microtask queue, therefore it will execute p1, which means it will execute promise 1, it will print p1. It means first listener 1, second promise 1. Now it will pick the callback 2 function. In callback 2 it has listener 2, set timeout goes to web DOM API and promise 2. So when it is executing callback 2, it will print listener 2 and then p2 means this promise 2. Then because of this set timeout function, the set timeout st2 is queued into the task queue. which means first of all from callback function listener 1 and promise 1 got executed, and from callback 2 listener 2 and promise 2 got executed, and at the end it set timeout 1 and set timeout 2. Which is the right behavior? We can test that in the code pane editor. So execute, let me execute the code. Here you can see there is listener 1 and promise 1 from callback 1, listener 2 and promise 2 from callback 2, and at the end it set timeout 1 and set timeout 2. So that's quite interesting and it's important to understand. I would like to mention one more thing. If we execute this function, if we execute this button programmatically, like if we do this button dot click, the behavior or the sequence in which this is executed is different. I haven't included that part in this video. If you guys are interested, I can create next video when the button is clicked programmatically, because it has a bit, because logic is a bit different. It's good to explain in different video rather than explaining everything into one video. And that's all. I guess it was useful, and I will include the link to my blog if you want to dive deeper into the topic, and you can watch several reference materials included in this blog, and try to find the root cause of the problem and try to fix your JavaScript bugs or issues. Yeah, that's all. I hope it was useful. Thank you. Thank you.